Moscow. I think Russia is a very dangerous place. 7 years ago I entered Russia, and since 6 years I'm married with a wonderful Russian lady.
Russian woman, yeah.
So we are talking today about testing and data migration. In Austria and Europe, we are a so-called civil engineering company that's an independent agency in the context of quality assurance and testing. Today, Sneed is with me, one of the famous guys in quality assurance and testing in Europe. He won the biggest software quality assurance award 2008 in America, so I'm very proud to be with him and work with him together.
Thank you.
I'll introduce Sneed.
Yeah, thank you. Yeah, we'll
It's
start.
your turn.
Yeah. So you can start with the presentation. Thank you. The company introduction.
Okay. Well, as I told you, we are a so-called civil engineering agency in Austria. We are testing software in different ways, especially migration projects and also security service. And what we do is we give official certification to the companies whose software we are testing. The company is 20 years old, and we are supporting the public administration, also private companies. So here now.
You don't want to say something?
No, thank you. This is quite enough. I will go to the next slide, and it's yours.
Okay. Well, I wanted to say something about the background of this project. Wolfgang's company is a certified quality assurance agent. This is an Austrian tradition already back in the times of Maria Theresa. They commissioned inspectors to check the military equipment which was sold to the Empress. And they acted in her interest, and later they kept this and took it over into the civilian area, so that contractors of the government have to pass through these inspections, to get their products approved, and it applies now to bridges and highways and whatever is built for the state, including IT systems. So we're talking here about an IT system which is being checked, validated by the certified civilian techniker in Austria. So I can't emphasize enough how different test projects are, because I've been working in testing now since 1976. I started testing for Siemens in Munich and developed their test tools for making module testing. Later, I went over to Budapest because there were no testers in Germany. No one wanted to test at that time, but they had a big system to test, a railroad system. And I happened to meet someone from Budapest. He said I should come there. They would have lots of highly qualified, intelligent people eager to test. So I went over there and we made a contract. And it was very difficult because Siemens was not about to pay an hourly wage or a monthly wage to a country in the Soviet area, in the communist country. The Comecon country, so they said we have to pay by result. So what are the results in testing? What do testers produce? They produce error messages, right? The error messages are accepted. They're not just faking the error messages. They're real, genuine error messages. Then they pay, at that time, what was it per error? 200 German marks per error. But we needed a second criteria that they would also pay for, and that was for test cases. So for every test case, which was unique, not just repeating the same case every time, then they paid another 75 German marks for this. And well, this went on for 1.5 years. We tested several hundred modules by extracting the test cases from the source code. So we actually were testing the programs against themselves. So later, when they put this system into operation and made integration testing, they discovered many problems. So they weren't completely satisfied, because in testing the code, you only test that the code runs. You don't really test, it does what it does, but not necessarily that what it's supposed to do. So that's why you need an oracle. You need something to test against. And that's when I then started with front-end quality assurance software requirements engineering. And in Hungary, we built some tools to help the users to specify their requirements. And then from the requirements, we could derive the test cases and test the system. So this is how I started in testing, and this was in the end of the 70s. So I was testing different places in Europe, in not only Germany, but also Austria and Switzerland. In the 90s, I was a long time in Switzerland at the Union Bank. Now, what about this presentation? This presentation is a very specific topic. It's about data migration, moving data from one database to another, but not only moving the data, but also restructuring it and changing the format, and also changing how the data is computed. So when I listen to the talks here about agile development and creating test cases on the fly, or exploratory testing, I see that fits very well to some situations, some, but not all. There are many situations where you can't do this. The testers are not involved in the development. Something is developed, turned over to the testers, and they have to test it. So you may say, that's not a good thing. The testers should be involved from the very beginning, including the requirements and so. But this is not true everywhere. You have situations like this, where they're migrating the legal documents from Austria from a Microsoft SQL driver over to a Postgres database and changing the format of the data. And this way you have to work more formally. Yeah. So we want to make a data content validation, old and new, and rule comparison. And that's what I'm going to talk about. This was the background. Here, as I've already mentioned, that 7 million legal documents, the contents of the 7 million legal documents are being moved over from one database to the other, not only physically migrated, but also restructured. Some data are recomputed, some data are separated from each other, some are joined. And the rules for changing the data, they were very diligent, the people that are responsible for this project. The 80-page data requirement specification with some 292 rules. So this is an experience report. You learn from the experience from others. And the company, the Civil Technica apprentice, was given the job of ensuring that the data is migrated correctly, that the results are correct. So if you were a tester somewhere and you were given this job, how would you approach this job? How would you handle it? So you have several million data items to check and stamp that this is correct. So there's only one possible solution, and that is automation. There's no alternative in many projects to test automation. And that's why, for me, testers have to be programmers also. Testers must be able to develop tools or to modify, tailorize existing tools to use. If they can't do that, then they're no great help to you. Yeah? So just getting people to feed in data and then scan through the results and say if they look nice or look correct or not, that doesn't help. We need test automators, who can produce the tools we need for this particular situation. So testers must be very creative. They're given a job, get from one point to the other. They have to find a way. And once they've found a way, they have to be able to automate it so that they can repeat it time and time again. Okay, this was the background on this project. So system migration, as you see here, we have user interfaces, there's code, and there's data, which is moved from one environment to the other. And we're talking here about the data. So no code and no user interfaces, but data. Oh, I see I'm going in the wrong direction. Okay. Not only that, but we're re-engineering the data. So we're refactoring the data. You can see with the normal forms, you'll see if we have orders and customer addresses and positions, then some of these should be factored out into another database table, and they're connected then by the foreign keys. In this particular database, they create XML objects, which they didn't have before. So you see there's a transformation here of the data which is taking place. So the challenge of data migration testing, the old data in the previous database is being moved over to the data in the new database, the new structure, but old content with specified modifications. So not all of the data is changed. Actually, over 50% of the data content remains constant, but many of the data are changed, recomputed. So we have these goals of database coverage. We want to test this sufficiently so that we can confirm with the agency which is paying for this data migration that the data has been correctly moved. So we want to test every possible type of data value in every field declared, test all the combinations of data values with any given record, test the different record types. We want to arrive at least 90% of all data value combinations are states, relevant states, and 95% of the possible data values generated should be tested. Well, with the record types, we should strive for 100%, but nothing is ever 100%, so we are also satisfied with 99. So here, we want to test all relevant values in all fields of all records. A field is only correct when all the values of that field, in different records are correct. A record, a tuple, is only correct when all the fields of that record are correct. So we have fields, those are data attributes. You would say in SQL, those are the columns. And in the columns, you have values. At the intersection of the rows and the columns, you have the values. And then you have the rows, which are the records. And a record is only good if all of the values in that row are good. You have to check all of them. A value is correct when it matches the old value, which is coming from the old database system, and it matches the value as computed by the rule, which means that your tool has to has to compute this value and compare the value with what's in the database. So we're actually writing a second program here, which does this. Now, we can see here the data correctness metrics, then here are records, they are rows in the SQL table. The columns, the attributes, and here are values. So we can check, 5 of 10 records are error-free, are 4 of 7 columns, fields, and maybe we don't show all the values here. We assume there's 100 altogether, but 5 of them are wrong. You have to prove this somehow by documenting it. Here are the database coverage metrics pertaining to, this was this. And here are the records, values. That's good. And then we can produce these metrics from a database validation run. You see here are the total number of data declared, the number of records paired, the number of records duplicated, the number of columns compared, number correct, total number incorrect, percentage check. So this is here. This pertains to the records. This pertains to the columns, the attributes. We have here 100% of all the attributes were checked, but only 54% are correct, and the incorrect is 46%. And here are the values in the columns. Before starting the test, we first want to analyze the schema of the databases. You know that the SQL data has a declare table statement where the structure of the database is there, names of the data for every column, and also the keys are identified. And there's a schema for the previous database, and there's a schema for the new database. So we begin by just parsing these two schemas, and then we compare them with one another to make sure they are compatible. That the data can be traced from one schema to the other. Then we want to analyze the data contents. So here you can see that the data attributes, keys are added, data types change. It may have been string type, now it's only character. Here is a type C, attributes are missing. C is over here, where is this? Attribute 3 is there, but this attribute 5, type C, is not here because there's only attribute 5, type D. So attributes can also be missing, and you can pick this up by comparing the schema statically. Then we can compare the data. That's difficult to find a word for this. it's not really dynamic analysis because we're not executing any programs. We're not running anything. We're just picking up the data and processing the data with a separate program. So we have here the database before the migration, feed it to the data validation tool, and the database after migration, and it's going to compare this at the data item level, at the field level. Besides comparing it with the old data, we have here in the scripts, we have the expected values. They are specified here in the script. So the easiest is just to compare the old value with the new value, wherever it is now, because it could be somewhere else. More harder is if the values are computed, and then we have to follow this computation and repeat it again. This is the data validation process here, which is showing that we read in the schema. It could be a text file, CSV file, XML, or SQL data table definition. And this is fed to an assertion generator, which generates the scripts, the assertion scripts. And this goes into the assertion compiler. The assertions prescribe the expected results. So they're compiled into symbol tables, and this is interpreted at the time when we process the database. So here's the reference data is fed in, the data that we're comparing with, plus the rules, and here are the actual results, which go into the data validator, and we get a deviation report and also a metric report, because the metric report is going to tell us how thorough our test is. So here you can see this data comparison, the original with the migrated. Sometimes like here, this data, you see here is 20 and here it's 21, for this record here with the key B. And here, this F is missing in the new database, and well, it's missing here in the old, the F, and this is the G missing in the new database table. So you can have values in one table, but somehow they were lost moving over to the other. To do this visually, I want you to stop for a moment and think about this. You're a tester. You have 7 million such rows. There are altogether 19 tables, And you should go through and compare them visually if they are right or wrong. This would drive you mad. You can't do this manually. So this is where improvisation comes in. A tester has to be imaginary. He has to imagine a solution. How can I solve a problem? In some way this has to be solved, and then I have to somehow make it economically feasible, the solution, that we don't need 50 man-years to carry out this comparison. So as I said before, the database schema is the source of the assertions. Here you can see a sample of a create table for customers, create table for addresses, create table for articles. This is just to show you what we are looking at in the schema. When we parse the schema, we see this data, and we can count the data, and we can check it to see if it's there. When we run the validation and compare the two databases, the old and the new, and together with the rules, then we're going to get something like this, yeah? So here the data is listed out for the data which is good. If there's no error in the record, it doesn't appear here. So otherwise this list would be much too big. So only appears here records that have some error in it. These are deviations. So then we can follow this up, yeah, and check it in the tables, you know, if this is really true, or maybe we mix the tables somehow, yeah. This is a sample of a test script for an XML file, so we can also compare not only SQL and comma-separated values, but also XML files can be compared. This is from another project. This is for the Chamber of Commerce in Austria. You can see here that they were checking their customer data, the birth date, this is the billing amount and so forth, the checking with the old. This was the work group that they belonged to, the different, divided up into different sections of the economy. I jumped one. This is the validation of the invoices, the bills that are sent out. So here you can see that there are often very minor differences in the data. Here, the difference is 1 digit. Here it's 5, and here it's 4, yeah? Or here 0, 0, and here it's 10, yeah? So now you see why we need automation, because the human eye is not trained to recognize such slight differences, yeah? So you have to compare this automatically. You can also compare with other tables. As you see here, you can say the attribute 4 is connected with attribute D in table 3, and attribute 3, if attribute 3 is the same as the key in A. So you have dependent attributes. These are dependent attributes. The key is found in the new database table, so in another table, in table 3, and you compare it with what's in the new table 1. Yeah. Oh, what's going on? So now I come to our case study. This is where I'll close out. Migrating these legal archives there in Austria. You can see samples here of how the data is specified. So these are genuine samples taken from the requirement document. You can see the new office numbers created by concatenating the old office number with the notary office counter and joining them with an underline. Or the new reference number is the deed number in the notary document of the original document. In the new records, an academic title is inserted after the family name, or the old country IDA should be replaced by AT. And from these rules, then, we write this script. So for another project for a big bank in Vienna, which was getting data from its Eastern European subsidiaries, I was able to automatically convert the informal rules into formal rules. I didn't do that here. There weren't so many rules. There were 262, so that you could do this manually, converting the rules that you just saw into this, was what the user wrote here. And we have to put it in this form because, of course, the parser cannot parse this unstructured, unformatted statements here. And this is describing, for instance, that this new street is the old street, then comes an underline, and then there's the house number. And if the new country should be AT, if the old country IT was A. Or here, these are possible titles for the person. There should be a title always after the name, and it has to come from this enumeration set. And then we run it through the tool, and it makes the comparison, and you see here the differences. That the Frau Baumann is missing from the old file table. The zip code, when it says old, it means it should be null, but it's 1020. The location is Wien, but it should be null, according to our calculation. And here the date, if you look at the date, you can see that the day is always off by 2. So these are errors in the migration program. And then we can sum up these statistics. We have the total number declared, the number of records paired, how many were duplicated, old and new. The records, 1086, were correct from 1226 compared. There were in this one test 2,970 values, and 2,714 were correct. That means that it's 86% correct, the values, but the fields is 91%, and this gives us a 9% correctness. So now comes the key question is, how correct does the data have to be before you can release the data? Now this is a question that the manager has to decide. So he could say, I strive for 99%, but he has to make compromises somewhere and say, maybe I have to accept 95% or 92%. And of course, you should always produce some kind of dashboard, which is done here, which shows that this is the data coverage is 86%. This is the degree of data correctness, and the data reliability is actually the coverage times the correctness. These other gauges here are showing the static characteristics of the database schema, whether it's testable or not. Do they conform with the rules? This has to do with the number of rule violations in the database. How efficient is the database, meaning in the length of the access paths, the data flexibility that you can change this data structure easily, accessibility, and independent from the application. That's measuring that. So, what can we conclude from this project? That migrated data should be controlled. It has to be validated by someone. So, I mean, you could do this when you're writing the migration programs, that you test them during the migration, or the developers can test them. But this is not really an independent test if you insist on independency as they do here. Testers, the developers may need special training for doing this data validation. You must control both the structure and the content of the migrated data. And for this, you have to write these scripts. Now, it's nice if you can generate the script from the requirement specification, which is in some projects possible, depends on the formality of the requirement specification. And the data tests must, of course, be repeatable. Yeah, with no additional effort, you can run it through the database time and time again, checking the old data against the new data, but also against the rules, and collecting metrics to compare with your goal. What did you want to reach? What degree of data coverage? Thinking of this columns, values, and rows, have all of them been tested or not? And then you can write your report for the customer and say, this data is validated. Yeah, that was it from my side. Now the questions can come. What tools to use for migration testing? Well, you know, comparison tools, comparing old data with new data, they've been around since the 70s. So, but they compare on a byte-by-byte basis, just physically, the data. So you can't really use them anymore. I mean, you need an intelligent comparison tool which allows you to compare the data at the field level, at the data item level, like account number and customer name, and so they have to be compared. Yeah. This tool here I wrote myself in 2005 in this project for the Austrian Chamber of Commerce. I didn't have much time, so this is the other problem as a tester. You're always in a new situation. So I'm wandering from one project to the other. I come in there and then I have to produce a tool within 2 months or 3 months. This bank project for checking the data which came from Eastern Europe, I had 2.5 months to write the tool and to confirm the data. So you're never able to really perfect the tool. So you have to be able to improvise and create a tool which is good enough for your purposes. But I think you recognize here that for comparing and checking huge data amounts, you need another tool than you would use, say, for FIT or Selenium or so. They don't fit into this category. Probably you have to do your own development. To be a good tester, is it enough to be a junior developer or senior developer? Well, you can start out as a junior developer, but actually this is very demanding, writing test tools. Yeah. So you have to be a good programmer, be able to make a stable system, because if your system is unstable, then you only create work for the testers. They have to work around your errors. Yeah? So it has to be well designed and robust. How do you handle a large amount of test output before correction? Well, I mean, what we do in this project, we don't go through and check the whole database. So we cut the data up into segments of the database. So that in any case, we check each table separately. So there's a run for each table. Here we have 19 tables, which means 19 runs. And if a table is particularly big, then we divide that up. That only becomes a problem if the data are cross-referencing to other tables, then this makes a problem. So it can be with over 7 million, up to now reached 7-8 million records, but if we had to deal with some insurance companies that have 12-13 million records, then that's a challenge. Somehow we have to break that up, divide it up. How do I count testability? Well, in programming, in the programs, if I'm looking at Java code, I count the paths through the code. So a piece of code, a component, should have a minimum number of paths going through that code. And you can analyze and capture the paths and compare that with the size of the component in statements. Here, the testability is a question of how easily is the database accessed. Can you access the data well? And is there a limited number of data combinations? So if the database becomes too complex, say you have too many fields in one row, then that's not good for testability. You want to have short rows, which you can more easily test. So you have short rows and you have fields which are disconnected. The loss of data is a great risk. How can we reduce this risk before migration? I'm not sure this is really a problem for the data validation. This is more for data security, that you don't lose data, but at least here you can recognize when data is lost. You can see that rows are missing, in the one or the other database table, and then you can take action, but this is not a solution here for preventing the loss of data. No. Any more questions?
That's all.
Yeah? Good. Thank you. Good. Thank you.